Ready or not, we're going to go. So I'm going to do this in reverse order. I'm going to do number 4, talk about it, then erase it. That'll give me room to do number 3, talk about it, then erase it, which will give me room to do 2. And then I'll do number 1 last. Okay, just only because I need room to do all these things. So, okay, let's start down here. If I clean up the numerator, I get -6. Clean up the denominator, I get 0. You can never have 0 in the denominator, ever, ever, ever. So this is a neither, because technically you're supposed to say not or undefined. You're supposed to say undefined. But I think last week, Lindsay reminded us that mom uses DNE, which is short for does not exist. So I would put that in the neither category. Okay, simplify that. Over here, the square root of -4, okay, does not exist also. Okay, it's okay. You could use does not exist, but I'm going to go DNE. If you tried that on your calculator, you'd get an error, because until we do something really weird, you can't take the square root of a negative number. Now, that's really kind of an important subtlety here. This is a square root. I don't know if you guys can see the red or not. I know you were yelling at me last week. You couldn't. You can take cube roots of negative numbers. You can take fifth roots of negative numbers, but you can't take square roots of negative numbers. So for us, for this problem, this would also be a neither. It's not rational, it's not irrational, it's neither. Same thing with this one down here. Okay, coming back to here. If we look at pi, okay, just about everybody knows that pi is approximately 3.14, and it goes on 1579, I think, something I can never remember what it is. But it goes on forever and ever and ever. The key thing here is because the decimal for pi goes on forever, okay, and very important, and there is no pattern to that. It is irrational. The decimal goes on forever, and there's no pattern, no repeating pattern. Therefore, it is irrational. Okay. This one, okay, is -3. Maybe I should use it on my calculator. There's a couple ways of doing this, which we'll talk about. Clear divided by 3.14285714. Now my calculator keeps going on like that. Okay. 3.1428571428. From that, we can pretty fairly assume that this is a decimal, but check it out, it's repeating. 142857, and then it started 1428. My computer probably ran out of room, but I'm going to make a guess that it's also 57. So this is an infinite decimal, but it's repeating a pattern. And because it's repeating, it's called rational. Okay, a rational number is a decimal, okay, that can either stop or repeat, and if it repeats a pattern. An irrational is a decimal that goes on forever and never repeats a pattern. So these two are very close to each other, but they're not the same. There's also another definition of rational, and that is anything that can be written as a fraction where the top number is an integer and the bottom number is an integer. Integers, okay? So anyway, I would say 4A is rational, For B is irrational. For C and for D, whichever one I had up there, those were both neither. Is that okay with everybody?
Yeah.
Any questions, complaints, concerns? Okay, need to erase. Can I erase?
Yeah.
All right, I don't hear anybody yelling. I'm also going to erase up here so we have more room. Okay, quiz on Thursday. We'll work until about 8 o'clock on Thursday, and then I'll give you the quiz. Okay, work until about 8 o'clock, then I'll give you the quiz on Thursday. I'll tell more, but it's a timed quiz. You'll have 1 hour to do about 15 to 18 questions. It is a timed quiz on Thursday. You have until midnight to finish it, but once you start it, you have 1 hour. So you don't have to start it right away. You can go over your notes, you can review, you can do whatever you want. Once you start it, you will have an hour, but it must be completed by midnight. Okay, and we start chapter 4 tomorrow. All right, back here. So in my mind, this is 5, absolute value -3, -3 on top. On bottom, okay, this is 6 divided by 2, parentheses 2 minus 2. Okay. On top, this is 5 times 3 minus 3. Remember, the absolute value takes, you first do inside the absolute value to the best of your ability. 7 take away 10 is -3. But then the absolute value takes that answer, -3, and always turns it positive. Okay, so 3. So finishing off the numerator, 5 times 3 is 15. Take away 3, this is 12 on top. So for my numerator, is that okay with everybody? Do inside the parenthesis or inside the absolute value, get -3. The absolute value -3 turns into +3. Then I follow PEMDAS, 5 times 3 is 15, -3 is 12. So that's my numerator.
So just a question.
Yeah.
So whenever I do the absolute value of something, unless there's like a plus or a minus sign in front of it, I'm just going to assume that we're timesing it by the 5.
Yes.
Like,
Again, this is back to the old math. When we shove things all together, it's implied multiplication.
Okay, got it.
That's the algebra. Yeah. Okay, good clarification. Okay, now on the denominator on the bottom, I saw the parentheses, 5 minus 3 is 2. So I have this, 6 divided by 2 times 2 minus 2. Okay, too many 2's here. Here's where I was hoping, well, I'm hoping not to trip you up, but I was expecting. Right here, we have a combination of multiplication and division. So what's the rule in PEMDAS? Remember, we have PEMDAS, we have P, E, M, D, A, S. If it's all multiplication and division, okay,
From left to right.
left to right, okay, you have to go from left to right, okay? So the next step has to be 6 divided by 2. This is 3 times 2 minus 2. You have to go from left to right. There is no choice here. When it's all, or when it's a combination of multiplication and division, you work from left to right. 6 divided by 2 is 3 times the 2. 3 times 2. So this is 3 times 2 is 6. Minus 2, this is 4. Okay, final answer, 12 divided by 4 is 3. Okay, so that's number 3. Questions?
I have a question. I'm not exactly sure why I'm having a hard time with this, but so it's 6 divided by 2, the parentheses 2. Oh, never mind.
You sure? That's the easiest question I've answered all night. Okay. This 2 here in parentheses is just the result of 5 minus 3.
Yeah, I was overthinking it, and I
Okay.
started to distribute the parentheses.
Ah, yes. No. Okay. You did like 2 into that? No. You can't do that.
How would you
Okay.
know when you can do that and when you can't? Like distribute, because I understand what the other student's saying, because
Okay.
that's what I wanted to do at first, but I got the
Wait.
same answer. I did get the same answer as you, and I did distribute. And I still got the 12/4. If that makes sense.
Okay, because you did 6 divided by, and you kept the parentheses 10
Mhm.
minus 6. So you kept the parentheses there. So
Mhm.
that was 6 divided by whatever that it was, 4
Uh-huh.
times minus 2. Yeah.
Mhm.
I don't know why you got the same answer. I take that back. Two times. I don't know why you got the same answer. There's another mistake in there somewhere. Huh. The 2 times 5 is 10 minus. No, that has to have been no. If you did that part right, you can't get the same answer. So I don't know what you did. But see, that's why the Pemdas rule, you have to go from left to right. 6 divided by 2 first times this answer. 6 divided by 2 is 3 times this answer minus 2. I'm not sure what you did. I don't know. We'll come back and revisit that a little bit later, maybe. I hope. All right. What'd you guys get for number 2? There's only 2 answers you can get.
I got 81.
Negative.
I
I got
got
negative
negative
81.
81.
Positive
Eight,
81.
okay, it's either 81 or negative 81.
I got -1. Negative
1?
81.
Okay, yeah, geez. Okay, negative is correct. Remember, this is first off one of my favorite problems to put on a test or a quiz. Okay, in the problem I wrote here, notice the negative is being powered. The negative is being affected by the 4th power. But in this problem, the negative is not being affected by the 4th power. All because of the parentheses there. So this first problem, the original problem was -1 times 3 to the 4th. That's how we see that. Okay. So this is -1 times 81. This is -81. Okay. But in this problem, the negative is being affected by the power, or rather the power affects all of them. So this is -3 times -3 times -3 times -3. Okay. Negative times negative is 9, positive 9. Negative times negative is also positive 9. So 9 times 9 is a positive 81. Okay. Again, students like to assume that there's parentheses in this problem when there isn't. Okay. So again, the only thing I can say is the negative, or the power rather, does not affect the negative in this problem, but it does affect the negative in this problem. I would, in your notes, put that example up as something that Foster likes and will eventually test. I can almost guarantee that's an exam 1 question. Okay, something like that will be on exam 1. Mom comes up with random numbers on this quiz on Thursday, so I'm not quite sure what's there. I know there's something like this, but I don't know what form it'll take. Okay, so -81, we okay with that one? Next. Okay, back up to this one. Okay, we started the evening, but not everybody was logged in at that time. This is 9 parentheses 2 times -3 minus -6 close parentheses squared minus 8 times 6. Okay, notice how I use, every time I use a substitution in place of the variable, x was -3, y was -6, I always use parentheses there. Okay, so this is 9 parentheses. This is -6 here. Minus minus becomes +6, quantity squared minus 48. So is that okay? How I got -6 plus 6? Are you guys okay with minus minus became a +6 in there? All right.
Yes, that makes sense.
6 minus 6 is 0. So this is 9 times 0 squared. Well, 0 squared is 0. This is 9 times 0. This is just a big fat 0. 0, take away 48. Final answer, -48. We okay?
Yeah.
All right.
Yes.
All right.
Yeah, it makes.
I want to erase this and move on to some more problems. Practice problems for us to do.
One
Are we
second.
okay? All right.
Yes,
Okay, here we go. Okay. These are all going to be solved. Number 1, 5 minus 2 parentheses 3x plus 1 close parentheses equals 2x plus 7. Number 2, 2/3 x minus 3/5 equals 1/5 x plus 2. And number 3, 2x plus 1 over 4 equals 3x minus 7 over 2. Okay, let's take about 5 minutes. I'll pause the video. I won't try the breakout rooms. I'll just let you guys work. If you want to go into a breakout room with Ann or me or somebody, we can arrange that. But I'll just let you guys work for about 5 minutes. Okay, this is chapter 2. Chapter 2 started with solving equations. So these are the three of the 4 types that we worked at. This is the one we started way last week using the 5-step method. This is one with fractions, and we're going to have to get rid of the fractions. And this is one I did one problem on. I did one example, but it's a really, really important one. That's why I wanted to kind of put it up here tonight. This was called a proportion. A proportion is when you have one fraction equaling one fraction. And you see these a lot in higher math classes. And people don't talk about it a lot. So I guess I've got a real burr in my saddle or under my butt or whatever it is on these. I really like proportions. They're so easy to solve. What we do with a proportion down here, I'm just at number 3, is we do something called cross multiply. We multiply the denominator times the other numerator. The denominator times the other numerator. We cross multiply. So we end up with 2 times 2x plus 1 equals 4 times 3x minus 7. Now, it doesn't matter who's on the left side and who's on the right side. It doesn't matter. As long as you have 2 times the 2x plus 1 equaling 4 times the 3x minus 7, it doesn't matter who's on which side. It'll come out in the end, it'll all be the same. Okay. So by cross multiplying, we suddenly taken all the fractions out of the problem. Okay. We distribute 2 times 2. This is 4x plus 2. Distribute the 2 in here, equals 12x minus 28. Okay. Then we began to have some really good discussions last week. People were talking about moving things around. Okay. How do I move something around? And somebody came up with a shortcut. When you want to physically move this 2 to the other side, let's say you wanted to do that. Okay. It was a positive 2, but the act of moving it makes it a negative 2. Or conversely, if you wanted to move this 28 to the other side, it's a minus 28. So you move it, it becomes a plus 28. Or the actual math says we're going to add 28 to this side, add 28 to this side. That gives us, I'll move up here, that gives us 4x plus 30, because we added 28, equals 12x. Okay, now we've got all of our numbers on the left-hand side, so we want to move the x's to the other. That was an implied to be positive 4x, so I minus 4x to both sides. That gives me 30 equals 8x. Okay, but because that's 8 times, I know that I have to divide to cancel out times, divide both sides. So I get 30 over 8 equals x. Now, I'm going to pause here. I'm not done. Okay, I got a little bit more to do, but those are my main steps for problem number 3. I cross multiplied because I have one fraction equaling one fraction. And when I do that, I can cross multiply, and suddenly the problem is kind of, I don't want to say simple, but it's a much cleaner problem. Then all I did here was I worked to get all my x's on one side, all my numbers on the other. And it doesn't matter x on which side. Okay, doesn't matter at all.
Question, Professor.
Yeah.
So can I, for the 3x minus 7 over 2, can I just times that by 2 to make it the same? Or is that way off?
Oh.
Because I got,
Hang on, let me finish this problem, and then let me come back and talk about what you did. That you did something really neat. Yeah,
Gotcha.
yes, you can do that. Let me come back and finish this one off. Okay.
gotcha.
Yep. And then I'll address yours. Okay. So is everybody okay with my work down to here? I'm not done, but are you okay with it?
Yes.
Okay. Then we had some discussion last weekend about what does it mean to simplify? Okay. Simplify is a fancy name for reducing fractions. Okay. So we can reduce this. For example, I can divide top and bottom by 2. Okay. And I get 15 over 4 equals x. Now, can you reduce this fraction any further? I don't think so. There's no number. The only thing that goes into 15 is 3 and 5, and neither of those go into 4. So this is a legitimate answer. If you wanted to change this to 3.75, if you wanted to knock that into your calculator, 15 divided by 4 is 3.75. That's cool. Full credit. If you wanted to use it as a fraction, 3 3/4, that's okay. A lot of times, read the questions on Mom. She will say, express your answer as a mixed number. This is a mixed number, 3 3/4. So sometimes Mom gets all pissy and moany, and you got to follow the directions. Okay. But for me, in general, I'll take 15 over 4 every day of the week. I will not take 30 over 8. It hasn't been simplified. Okay, 30 over 8 has not been simplified. 15 over 4 has been reduced as far as it can do. It's called improper, but it's acceptable. But this is okay and this is okay. So that's it for number 3.
I
Yeah.
don't know what I'm doing wrong. I got negative 8x equals negative 30 for that.
Nothing. You just had your X's on and your 30s on the other side. But think about this. Okay, you have negative 8x equals negative 30. You didn't do anything wrong. When you divide both sides by negative 8, okay, what happens to a negative divided by a negative?
Makes
A
a
negative
positive.
positive. So it still is 30 over 8. Same answer. You're fine. You're cool. I mean, you still have to reduce it and everything. But see what happened, you got your X's on the left side and your numbers on the right side. I got my numbers on the left side and my X's on the right. How come? I don't know. I just did. But in the end, it will all work out to the same answer. So you did nothing wrong. You're 100% perfect. You okay?
Yes, sir. Thank you.
Sure. All right. That was Bert that asked me about multiplying the bottom one. Was that right? Or
Yes,
Vince,
sir.
I mean, Vince?
Oh yeah, Bert's cool.
Well, no. Okay, you got 2 first names. I'm confused. Sorry. Okay, I need to erase this a little bit to show you what he's talking about. So can I erase the work for number 3? Anybody have any questions or concerns on that? Okay, I'm going to assume no one's going to yell at me. So let me show you what he's talking about here. And it's a really cool idea. He noticed that, hey, this fraction, this denominator is twice as big as this denominator. Twice. So he said, why don't I multiply this whole fraction by 2 on top and 2 on bottom? Now that's kind of important. If you change a fraction, you have to change the top and bottom by the same amount. Multiply top and bottom by 2. Divide top and bottom by 2. Whatever. You got to do the same thing, top and bottom. So if you do that, then you get, oops, then you get 2x plus 1 over 4 equals 6x minus 14. Is that right? Yeah. Distribute the 2 into here over 4. Okay. Now, big drum roll, because look, if 2 fractions are equal, and the denominators are the same, then what's the only logic you can say about the numerators? If 2 fractions are equal and the denominators are the same, then doesn't that imply the numerators have to also be the same? Okay, if 2 fractions are equal and the denominators are the same, then the numerators have to have been the same. And so this becomes this problem. We just sort of dropped the denominator because it didn't do any good once they were the same. And that would get you the same answer we got. And it's a perfectly legit way of doing this problem. So next time I'm going to watch out for that. See, because if I put a 3 here, then you're screwed. If I said 3x minus 7 over 3, then you couldn't use this trick. But it was fine. What I had here was great. And what you did, you attacked it correctly. So Vince, you okay? Okay. So I'm going to erase. And we'll go on to number 2. No yells. All right. Number 2, equation with fractions. the game we played was find the common denominator. In this case, the common denominator is what do 3 and 5 go into? 15.
15.
Right, 15. 3 and 5, and technically there's a 1 here, but that's kind of boring. 3 and 5, 15 goes into all of them. So then what we do, the technique, now, several of you said you use something different. Cool, that's okay. Show me your work. If it's legit, I'll give you full credit. But the new thing I'm trying to get you to learn is to distribute the LCD. So this becomes 15 over 1 times 2/3 x minus 15 over 1 times 3/5 equals 15 over 1 times 1/5 x plus 15 over 1 times 2 over 1. Okay, now I'm going to say something that's really kind of scary. I totally accept that some of you can distribute the 15 here in your head and reduce this in your head. I accept that. I accept that some of you can do this and say it's 10x. 15 times 2 is 30, divided by 3 is 10x. Some of you can do that, but you do need to show me this 10x. How did I get the 10x? Just reduce the fractions right there. Do the fraction multiplication. Do them on your calculator, do them in your head, do it on scratch paper. I don't care, but that becomes 10x. Here, this is 15 times 3 is 45 divided by 5. 45 divided by 5 is 9. So minus 9 equals 15 divided by 5 is 3x, because there's an x there, plus 30. Okay, so I'm going to pause there for a moment while you guys catch up with me. We found the least common denominator. It was 15. 3 and 5, 15. You distribute the 15 to every single piece of the problem. And if you don't make any mistakes, the fractions should all drop out. Okay, this 15 should have canceled with all of those denominators. And it did. Okay, any questions to this point?
No.
All right. So, okay, real quick, I'm going to knock through this. I'm going to take 3x away from both sides. That's going to give me 7x minus 9 equals 30. So I want to move the 9 over, so I'm going to add 9. That's going to give me 7x equals 39. Okay. Divide by 7. Divide by 7. 7 doesn't go into anybody, so its x is 39 over 7. And remember, if you want to call that 5 4/7, or you want to go to the decimal and do whatever you want, that's your business. Just do it right. Don't make any mistakes, but I'll give you full credit for that answer. So why do more work when I'll give you credit for that answer right there? So there's a problem with fractions, an equation with fractions. Questions? Now I did speed up at the end. If you want me to slow down and show you more of my steps, I'll be happy to. But the key to me was distributing the LCD and simplifying it down to this line right here. Okay, can I erase and do the number one problem?
No,
Okay,
Professor, did you say that when we leave it as x equals 39/7, you get the full marks, or we have to break it down?
that depends totally on the directions. If the
Okay.
directions don't tell you, then you can leave it there.
Okay.
But mom sometimes gets all weird and she wants a mixed number. And so that's where you go 7 goes into 35 5 times and 4 left over. That would be called a mixed number. But if I don't give you any directions, then 39/7 is cool. Take it. Anybody else? Okay. Need to erase, go on to the last one. Okay, no one's gonna yell at me?
No.
Not yet? Okay,
You're good.
thank you. I'll tell my wife you said that. She won't believe it. Okay, here we go. So, do I do 5 minus 2?
No.
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 First step was distribute. So what I'm distributing is the -2. So this is 5 minus 6x minus 2. I'm distributing the -2 into the parentheses. If you said 5 minus 2, you just violated Aunt Sally. And she's kind of pissed off, okay? You have to do the distributive first. Okay, have to. That was number one rule. It said distribute to remove parentheses. Okay, so that has to be it. Equals 2x plus 7. Okay. Oh man, I know what I forgot to show you. Shoot. Oh well. Okay, so we combine like terms. We have negative 6x plus 3 equals 2x minus 7. Okay. Take away 3 from both sides.
It should be +7, Larry.
It should be plus 7. Thank you very much. I was just checking to see if you're paying attention. Yep. Okay. And you're laughing at me. Okay. Negative 6x equals 2x plus 4. 7 take away 3 is 4. Okay. Take away 2x. And what do I have? Negative 8x equals 4.
Where'd your 5 go?
5 take away 2 was 3.
Oh, I got you.
You okay? You sure?
I got messed up there because I did 5 minus -2 instead of 5.
Okay,
Yeah.
think about this. This is 5 minus 2. You had 5 minus a -2. What's minus negative become? Minus minus becomes plus, isn't it? If I heard what you said 5 minus a -2.
Mhm.
Once you do the distributive, there's no more parentheses there. So the 5, I'm not sure how to explain that. It's just minus
You
2
combine
times
like
1.
terms.
Well, that's what I did, but I'm trying to kind of get in their head and figure out why
It's okay.
why it's not this.
Yeah.
Okay, you put an extra minus in there, so it was originally 5 minus 2. That's what I see here. 5 minus 2. Okay,
That's the
you
negative
put an
6
extra
and
minus, so you turned it into 5 plus 2. So you had a 7, so you probably had something like 0 for an answer or something like that.
Yep.
Yeah. Okay, now, here's first thing I see. Want to get everybody down to here. what I see here is students get in such a big hurry at the end of a problem. They say, oh, look at that. 4 goes into 8 2 times. So the answer is x equals 2. Oh, -2. I'm sorry, because it's -8 there. People get rushed. They say 4 goes into 8 2 times. The answer is wrong because you're rushed through it. Okay. Who are you trying to move? Who are you trying to get rid of?
-8.
-8. And it is multiplying. So you have to divide by the -8. And you have to divide this side. Okay. At this point, it's a fraction. This is x equals -4/8. Remember, we talked about how you could move the negative sign anywhere you want. 4/8 reduces, so you get x is -1/2 or -0.5 or negative whatever. But what happens, my point here was people get so, oh, wow, I'm almost done. 4 goes to 8 2 times. And they put a 2 down. But you're going too fast. You didn't follow all the steps. You started doing things in your head and that got all screwed up. Okay.
Quick question.
Sure.
So I did it the opposite way. So I subtracted the -7, or sorry, the 7, made it -7.
So you
And
have -4 equals 8x this way.
Yes.
Yeah.
So I got 2, but you're saying it's half.
No. How'd you get 2?
I divided the -4 by the 8.
Okay, that's the whole point. You're trying to get the x alone, right? You want to get rid of the 8. What's the 8 doing? It's multiplying. So the only thing you can do is divide.
Oh, okay. I see what I did wrong. Okay, thank you.
Yep. Okay. All right. Last thing we want to do. This is the last of the review, then we'll get off into new stuff. Okay. All right. So write in interval notation. Okay, we'll call this number 1. So 1a. If you had this graph, whoops. And it looks something like that with shading. Could you write it in interval notation? 1b, don't shout it out. I want people to work on it. Okay. 5. Arrow this way. And 1c, -4, 3, shaded that way. And I want you to solve, then express solution in interval notation. Okay. 5 minus 7x is greater than or equal to 2x minus 4. Okay, so the first problem, this is the last of the review, then we'll get into new junk. So the first one has 3 parts. Just express them in something called interval notation. Check your notes on that. If this is your picture, how do you do it in interval notation? This is your picture, interval notation, and so on. Then number 2, I want to solve this inequality. And when you get to the answer, express it in interval notation. Okay. So let's pause and let you guys work for about 2 minutes. Okay. Back over here. We had the old way to do this is also known as set notation. And this would be x is greater than -2. Whoops, let's write that differently. Okay, literally that's what the picture is saying. Here's -2, x is everything bigger than -2. That's what that says. It's not equal to. However, in interval notation, we put parentheses, -2, comma, and it goes forever. So we say infinity. So this is the old way that we would do it. This is called set notation. X is greater than -2. Okay. The new, more modern way is called interval notation, and it describes exactly what I see on the number line. I see -2, and everything is shaded to the right of that out to infinity. We use the parentheses to indicate we can't quite touch -2 or infinity. That's what the open circle meant. We can't touch -2. We could get real close to it, but never get there. And of course, we can never reach infinity. Okay, despite Buzz Lightyear. Okay, this one, the old way, the set way, would be x is less than or equal to 5. Okay. It's smaller than 5. We're going to the left of 5, smaller than 5, less than or equal to, equal because it's a solid dot. So this is the old way that we would do it. The new way is to say, what do I see on the number line? Well, everything is shaded from -infinity all the way up to 5, but we put a bracket on the 5. Okay, so the difference for us mathematically is a bracket means we equaled 5. We could touch the 5. A parenthesis means we can't touch those numbers or those things. Again, you still can't touch infinity. Even if it's -infinity, you can never, ever reach it out here. You can never stop on it. So the one up here, this is called set notation. X is less than or equal to 5. This one down here, -infinity, comma 5 bracket, that's called interval notation. Now, I talked about these last week. I never showed you this one. Okay. This one is, I'm going to give you the interval notation first. Interval. Okay. This is parentheses, -4, comma 3, bracket. Interval notation mimics exactly what we see on the number line. I see everything shaded between -4 and 3. That's exactly what that says. Again, we can't hit the -4 because of the open circle, so we use a parenthesis. We can hit the 3 because it's a closed circle, so we use the bracket. Okay, now we introduced that one last week. We did a couple problems kind of like that, but that's all new, so I'm more than happy to go over that. Oh, the set notation is wacko. It's -4 is less than x, which is less than or equal to 3. That's the set notation. And people don't like it. That's why interval notation was invented. Okay, don't worry. I only ask for interval notation. So don't worry about this set stuff, even though I throw it in there. What I'm more concerned with is the interval notation. This one, and this one. And my pin's dying. So how are we on interval notation? You guys okay?
Is there any like trick to remembering the brackets and the curves or the
Can't touch it.
I just completely blanked that.
I would memorize this problem right here. To me, that shows me everything, because the open circle and the parenthesis and the closed circle and the bracket, these two mimic each other. So that kind of helps me relearn it. I know exactly what you're saying. That's the thing that screws up students. They get the parenthesis and the bracket all mixed up. I don't know an easy way. Other than this one example is a great one to put in your notes because it shows you both possibilities in the same problem. I know that's not satisfactory to you.
So the closed circle is the bracket.
Correct.
Thank you.
Actually, some textbooks, okay, just to confuse you more, just what you needed. Some textbooks don't even use the open circle, closed circle. They actually do this. They put the parenthesis and the bracket actually on the number line instead of an open circle, closed circle. So
yeah,
that
would
makes
make more sense to me.
Okay, then you can do that. But then that's negative, oops, that's -4 parenthesis with 3 bracket. Okay. So
Sorry.
hang on one second. But the problem is you guys are stuck in the middle of mathematicians can't make up their minds. Okay. Mathematicians still don't know, oh, geez, do I like set notation? Do I like my graphs have open and closed circles? Do I like my graphs have parentheses in this? Do I like interval notation? Math can't make up their minds. So they said, you know what? Screw it. Students got to learn it all. And you guys are stuck. There's a question. I'm sorry.
It wasn't a question, more of a statement. I was thinking if you cut the open circle in half, then it's 2 parentheses. You can't touch it.
Okay. You guys catch that? If you cut the open circle right down the middle like that, then it shows you the parenthesis. Okay. Somebody's looking for a trick. All right. Let's go through this real quick. Okay. Those of you that had an 8 o'clock appointment with me, let's go to 8:15 because we got a lot of important stuff. Don't stop me yet. Okay. So this is an inequality. Again, we pretended in our minds to say it was an equal sign. So we treat it just like an equal sign. So I don't know. Okay. I'm going to take 2x away from both sides. That's going to give me 5 minus 9x greater than or equal to -4. Okay. Now I've got all my x's on the left-hand side. I'm going to take 5 away from both sides. That's going to give me -9. X is greater than or equal to -9. Okay. Now comes the fun. I have to divide, because that's 9 times x, I have to divide by -9, divide by -9. Have to do that. I don't have a choice. Okay. That's going to give me x. That's going to give me 1. But what happens when I divide both sides by a negative number?
You flip
You flip
the
it,
sign.
right? So it becomes x is less than or equal to 1. Now, we're going to do this problem a second time, and you guys are going to kind of see something else. This, if we graph it, I didn't ask you to graph it, so you're not on the hook for this, but if you graphed it, here's 0, here's 1, we want to be less than or equal to 1. So I'm going to use a solid dot, and I'm going to shade this way. So this is set notation. X is less than or equal to 1. This is its graph. And then in interval notation, it would look like negative infinity, comma, 1, and a bracket on the 1. Okay, now that's the right answer, and there could be a whole lot of questions there. Okay, again, we pretend mentally that instead of a greater than or a less than problem, it's an equal problem. And we follow all those dumb rules, those dumb equal rules. Okay, follow them all. We get x is less than 1. Okay, there's the graph. I didn't ask you to graph it, but it's good to see it. And there is the interval notation. Questions on that one?
I'm so sorry. How do you decide whether it's so when you get x is less than or equal to 1, how do you know if it's going to be filled in or an open circle? Sorry if you already went over that.
No, the equal sign tells me we're going to touch it. We're going to equal 1. So that means it's a solid circle.
Got it. Okay, thank you.
Okay. No, don't be sorry. That's a good question. This is new. This is confusing. Good question. Anybody
Professor,
else? Yeah.
yes. When you flip the what is it, the greater or less
Yeah.
than
The inequality symbol. Yeah.
It's only when it's two negative. When you're,
No, it's only when you divide by a negative. It's not the two. Well, maybe we're not talking about the same thing.
no, yeah.
Look.
Okay, so it's only divided by negative.
Right. So let's say you had negative 3x. I don't know, is less than 6. Okay. You're still going to flip it because you have to divide by negative 3. I don't care. This answer is negative 2. I don't care what this is. It's how did I change the problem? I changed it by dividing both sides by negative. So this is x, this is negative 2. Because I divided by a negative, that flips over. Okay?
Got it. Thank you.
All right. Anyone else?
Yeah, so in the beginning where you went minus 2x to each side, I did it opposite. So I added 7.
Okay, good question. And that was going to be the next thing I'm going to show you.
Okay.
That's a really good question. And I'm not sure I have the cleanest answer for you. So bear with me on this one. When it was a simple equality, just if, let's say the original problem had been an equal sign, then it never matters what side we put the x on. It doesn't matter at all. And you guys asked me that, tonight we did that a couple times. Some of you had the 8x on one side and the 4 on the other, and some of you had it reversed. Okay, those were all equalities. But when it's an inequality, it is safer. Notice I didn't say required, but it's safer if you put your x on the left-hand side.
Okay.
When it's an inequality, it's safer if you maneuver your x to be on the left-hand side. Okay. Now, having said that, let's take the same problem. And let's do it. And I'm going to move the x to the right-hand side and show you how you get around it.
Okay.
Okay. So I'm going to do what you said. You said you added 7x to both sides, right?
Mhm.
So that gives us 5 greater than or equal to 9x minus 4. Then you added 4. That's fine.
Yep.
And you get 9 is greater than or equal to 9x. Okay. And then you divide by 9 and you get 1 is greater than or equal to x. Okay. Here's the problem. Where do you shade? Where do you shade? Okay. When x is on the left-hand side, you always shade the way it's pointing. Somebody mentioned that the other night. I think it was Mitch. Okay. When x is on the left-hand side, then the inequality is pointing in the direction you shade. When x is on the right-hand side, we're screwed up.
Okay.
But wait. We can get around it. We're gonna use logic. Okay. Okay. How old are you?
Me personally, 29.
29. Okay, I'm 70. So listen to this. Two statements are identical. I am older than you,
Mhm.
or you are younger than me. Okay, those two statements are identical to each other. Do you agree with that or not? I'm older than you, or you're younger than me. Well, one is bigger than x,
Mhm.
or x is smaller than 1.
Okay, I gotcha.
1 is bigger than x. Remember, greater than, it means bigger.
Mhm.
1 is more than x, which is the same thing as saying x is less than 1, smaller than 1. Now you have x on the left-hand side. Now it's easier to graph, easier to put in notation. Okay?
Yes, thank you.
Okay. Now, so bottom line, it doesn't matter where you put it as you're doing the problem, but just at the end, to be safe, make sure x is on the left.
Gotcha, I can do that.
Okay. And I just showed you a trick way. Now I can show you a really confusing way, but that's the easiest way to just flip it around.
Gotcha, that works. Thank you.
Okay. Anybody else? Okay. Now we're going to get into new stuff, brand new stuff. So draw a line in your notes. You can write chapter 2 new. Okay. Chapter 2. These are called absolute value equations. Okay. Now, first, we're going to isolate the absolute value. Second, we're going to split into two equations. Okay. And solve each. Third, we're going to put two answers in these funny symbols, which I'll talk about. Those are braces. Okay. Key step here is isolate, which I'm not going to do it right away. I need a pin that's not dying. This one does. Okay. So let's take an easy problem. Absolute value 2x minus 1 equals, I don't know, 11. Something like that. Okay. Let's go back. Let's go back before I do this problem. If you have the absolute value of -3, the answer is +3. You guys all agree?
Yes.
And
Yes.
if you have the absolute value of +3, what's the answer?
3.
Still 3. So check this out. The answer is 3, but the inside could have been 3 or -3. We don't know. The answer was 3, but the inside was either 3 or -3. We don't know. So think about this. What if I said the absolute value of x is 5? The answer is 5. But what could have been inside here? X,
-5.
X could
or
have been
5.
5, or X could have been -5. We don't know. All we know is that when the answer to an absolute value is positive, but the inside could have been positive or negative, we don't know. That means when we're solving an absolute value equation, we will always get 2 answers, or 99.9% of the time we'll get 2 answers. So let me show you how we're going to attack this. This says the answer is 11, which means the entire inside could have been either worth 11 or it could have been worth -11. We don't know. So from this, we write 2 equations. We say 2x minus 1 could have been worth 11, or, and the or, by the way, is mathematically necessary, but I'm not going to take off if you don't write it. Or 2x minus 1 is -11. Look at the logic, and then we'll finish solving this. The answer was 11. That meant the inside quantity, the whole thing inside, could have been worth 11. But it also could have been worth -11. We don't know, so we have to deal with 2 possibilities. We solve each one. Okay, we're going to add 1 to both sides. So this is 2x equals 12. I'll skip a step. X is 6. Over here, we're going to add 1. Be careful. This is 2x equals -10. This is x is -5. Okay, now, in the correct way to answer this is to put these funny braces and put 6 and -5 inside those braces. Mom doesn't do that. Okay, but that's the correct math that when you move on to higher level classes, they're going to require that. This is called the solution set. Okay, and it's identified by these funny braces. Anything in there is your answer. Okay, and you always use this if it says solve and it's an equation, then that should have been, your answer should be in there. So all along, all these problems, when we had x is -2, we should have added 1 more step to look like that. That's the correct mathematics. If we did another problem where we had x was 1/2, we should have done 1 more step where we put the 1/2 in those funny braces. Okay, that's correct mathematics. The funny braces is math way of saying, hey, everybody, hello, wake up, pay attention, because any number inside there is the solution to my problem. It's like special symbols that say, look here, solution, solution, da. Okay. I'm going to be pushing that, but at least for the first test, I'm not going to penalize you for that. Okay. Too much new is happening. I'm going to be really happy if you have 6 and -5, but the key is you put them together in one answer. You don't leave 6 over here and -5 over here. Bring them together as one answer. This is the solution for that problem. So let's try another one. Look what I did. It's already isolated. I'm not tricking you. Isolate means get it alone. I'll show you that in a minute. Split it up into 2 problems, solve each one, throw them in a solution set. So with that, we'll pause. And you guys can try this. Absolute value on 6x plus 3 close equals 2. I'm going to pause this. Okay, so again, using similar logic, okay, the answer is 2, which means this quantity could have been worth 2, but it also could have been worth -2. All we know is the absolute value of 2 is 2, or the absolute value of -2 is 2. So we write 2 problems. We say 6x plus 3 could have been worth 2, or 6x plus 3 could have been worth -2. Okay. Solve each problem. -3, -3. So we get 6x equals -1. 2 take away 3 is -1. Divided by 6, x is -1, 6. I'm skipping a step here. If you need me to show it, I'll be happy to. Okay. Over here, excuse me, take away 3, take away 3. We get 6x equals -5. Divide by 6, x is -5, 6. So we get 2 answers. Okay. Remember the new topic or the new idea is the solution set. These 2 numbers go in here. Those are the 2 solutions that we have. This problem has 2 solutions. And we put both of those solutions in those braces. Okay. And it doesn't matter who comes first and who comes second. The order doesn't matter as long as the 2 numbers are there. Are we okay?
Makes sense to me.
Yeah.
Yeah. Until you do your homework.
Yeah.
Yeah. Okay. So can I give you a harder problem?
Yes.
You guys
Yeah.
ready? Yeah. Go for it. Yeah. Okay. Yeah. All right. Now remember, what the first step I had up here was isolate the absolute value. What that meant is you have to get it alone before you split it. So let me see if I can come up with a problem to explain that. I don't want a fraction.
I'm not sure if anybody asked this, but it doesn't matter if you do like -5/6, comma, -1/6, like switch the answers.
No.
Does that matter?
No, the order doesn't matter.
Okay, thank you.
Let's make this 10. Okay. I think that'll work out. All right. So 5 minus 3 absolute value x minus 7 equals -10. Okay. Let me walk you through this one to make sure you got it. You cannot split it into two parts yet. You can't. Okay. Absolutely you can't. You've got to get rid of the 5 and you got to get rid of the -3. And worse, and this is super important, 90% of the time you can't distribute into an absolute value. You can't do that because of what an absolute value does. It changes numbers. It changes negative numbers into positive numbers. Okay, so you can't distribute into an absolute value. It's a very limiting problem or function. Okay, so we have to isolate the absolute value and we can't distribute in. So watch what's going to happen. I'm going to take away 5 from both sides. Okay, that gives me -3. Absolute value x minus 7 equals -15. I still can't split it up because the absolute value is not isolated. I got to get rid of the 3. Isolate means by itself, totally alone. Okay, I got to get rid of the 3. Well, the 3 is multiplying. Okay, so I'm going to divide by -3. Okay, that gives me here the absolute value of x minus 7 equals 5. Now I have isolated the absolute value. It's just an absolute value. It doesn't have all this other junk around it. Now, and only now, can I split it into the two parts. Okay, so we say when we do the splits, we say, okay, for this absolute value, the answer was 5, which means it could have been a 5, or it could have been a -5. Okay, so we write it as x minus 7 could have been worth 5, or x minus 7 could have been worth -5. Okay, add 7. So x could have been worth 12, or add 7. X could have been worth 2. Solution set, 12 and 2. Okay, and again, whoever was asking that question earlier, I have 12 and 2. You could have had 2 and 12. It doesn't matter as long as you got those two numbers there. So this is an example of having to isolate. Wait a minute. Hang on one second. Okay, we're okay. Having to isolate the absolute value. We had to get rid of the 5. We had to get rid of the -3. Okay, before we do the splits, before we split it up. But absolute value is a pain in the rear. Actually, I was going to say something else, but that wouldn't have been professional for me to say pain in the ass. So I won't say that. Okay, you can't distribute a number into the absolute value. It works about 40% of the time. The other 60% of the time, you fail. It's not worth learning how to do that. How are we doing? We're doing okay?
Question. So we wouldn't do 5 minus 3 first?
Nope.
It has to be an individual number?
Yeah.
Okay.
And it's always the one on the left side, like the farthest left, or
Think
sorry.
of PEMDAS. Yeah, think
Okay.
of PEMDAS. Think equation solving is actually reverse PEMDAS. PEMDAS. This is for arithmetic. PEMDAS was introduced for arithmetic. But when you're doing equation solving, you're doing reverse PEMDAS. You're going this way. First, you undo the addition subtraction. We did. 5. Got rid of the 5. It was a plus 5, so I minus 5. Then you undo the multiplication division. Well, that was 3 times, so I undid it. And then you undo this other stuff. So equation solving is almost like reverse PEMDAS. Okay, get rid of the addition subtraction first, then get rid of the multiplication division, and then see what happens to the rest of it. Okay. Yes, no? Let me give you one problem to try on your own, and we'll move to the last topic of the evening. I spent too much time on the review. Okay. 12 plus 2 absolute value 3x minus 1 close equals 22. 12 plus 2 absolute value 3x minus 1 equals 22. Okay, let's pause it and have you guys start that. Okay. So if we kind of follow what I did over here, I'm going to take 12 away from both sides. So that's going to give me 2 absolute value 3x minus 1 equals 10. Now I'm still not isolated. I got to get rid of the 2, but I know that it's 2 times, so I divide by 2, divide by 2. That gives me 3x minus 1 absolute value equals 5. So if I were grading your papers, that would be a key step I would look for. Here would be the problem. And you must get to this step. You have to isolate the absolute value down to this step. So are we okay to there? Anyone? Everybody's happy? Okay. So again, we play the game. Okay. This quantity could have been worth 5 because the absolute value of 5 is 5, or it could have been worth negative 5. This quantity could have been negative 5. So we split it. 3x minus 1 equals 5, or 3x minus 1 equals negative 5. Once again, notice, really important, the inside doesn't change. Okay, it stayed 3x minus 1. What changed was it could have been worth 5 or it could have been worth negative 5. But the 3x minus 1 doesn't change. Okay, solve, I think this becomes x is 2. Add 1 divided by 3. This becomes negative 4/3. I think so. And I'll show work if people want me to, but the solution set is 2 and negative 4/3. And again, it doesn't matter which order you put them in as long as you got those 2 numbers there. So do you want to see my steps for how I got 2 and 4/3, or are you happy and we go for it?
Can we see your steps?
And I
I'm
see.
so sorry.
What?
You go ahead. Sorry, someone else was asking something.
You want to see the steps?
Yes.
Okay.
Yes, please.
Yes, please.
Both of them? Okay. So, all right. Are we okay to the isolation step here?
Yes.
Are we okay to the split?
Yes.
Yes.
Everybody's there.
So
Okay.
the 2 times 3x plus minus 1, you said that that works some of the time, but not, or most of the time, but not some of the time.
Now I said don't distribute in. About 40% of the time you can distribute into an absolute value. 60% of the time you cannot, and it'll screw up your entire problem. So it's safer to never distribute into an absolute value. Okay. You could have done it on this problem and gotten the right answer. But generally, it's safer never to do that. Okay, so here we go. I'm going to add 1 to both sides of this problem, giving me 3x equals 6. 5 plus 1 is 6. Divide both sides by the 3, and I get x is 2. Okay, one answer. The other answer, add 1 to both sides. I get 3x is -4 equals -4. Divide both sides by 3. I get x is -4/3. Again, if you want to call that -1 1/3 or -1.3 with a bar over it, that's up to you. That's an okay answer for me. Put them together in one big giant solution set, 2 comma -4/3. Okay or not? Did you guys wanted me to show my steps? Is that okay? Or do you want more of an explanation?
I just have one question.
Sure.
The answer with the fraction, does it still not matter whether you put a mixed number or
Correct.
the 4/3?
Yeah. 4/3, -1 1/3. If you call this -1 1/3, if you call this -1.3 with a bar over it, all of those are legit answers. My rule of thumb is I'm going to take the simplest answer possible. This is acceptable. This required me to do one extra step. What if I made a dumb mistake? Just a dumb, silly mistake. Okay, then you're going to lose some kind of credit. Okay, this is acceptable. This, you put it in your calculator. What if you have fat fingers like I do and you put it in your calculator wrong? Then I got to take points away from you. So the one that requires the least amount of work is the best answer. That's it right there. But these would also be acceptable.
Okay, thank you.
Sure. Okay, that's absolute value problems. Right, I need to erase this and go on to tonight's last topic. It'll take me maybe 7 minutes, and then I have a way I'm going to take roll, and we're going to be out before 1/4 of. You guys hanging in there?
Yep.
Yep.
Okay. All right. Okay.
I wrote it down wrong, I think. That's why.
I'm sorry, I just erased it. Okay, am I recording this? Because I don't know that I want to. Okay. All right, here's a very, very technical math term. Weird math equations. Okay, there you go. I want you to solve this problem. Whoops. Okay, take a second, solve that problem. So right about now, you should be confused because you got a weird answer. Yes or no? Probably.
Oh no, I lost the
Yes.
X.
All right, so if we distribute in, we get 6x plus 12. 3 times 2, 3 times 4. equals 6x minus 9. Okay. If we get our x's together, if I take 6x away from this side, I have to take 6x away from this side. All of a sudden, my x's drop out and I get 12 equals negative 9. Okay. I term this, and actually I keep using this when I talk to other math instructors. I call this a WTF equation. Okay. Because it doesn't make sense. Something weird is happening. Something very strange is happening. How can 12 equal negative 9? That's impossible. WTF, impossible. So my first inclination is, okay, I'm going to go back and make sure I haven't made any mistakes. I haven't. Okay. So this introduces a new concept for us. Some equations have no solution. No solution. And so mom will say something like, right, no solution. The correct math way is to put those funny braces that I introduced and put nothing in them. So this is mom. I believe she says, right, no solution. Okay, and this is math. Okay, I'll accept either one. But all of a sudden, just when you thought, okay, I get this equation solving stuff, I got it, all of a sudden we're going to throw problems at you that have no answer. There's no solution to this problem. So this is the proper way to say the math. No solution is what mom likes, and a lot of other instructors like. The proper math is to use these funny braces and put nothing in them, because literally there's no answer to this problem. Okay, try this one. Okay, I'll pause it while you try that one. 7x plus 14 equals 7 times x plus 3 minus 7. Okay, so if we go through the steps, we get 7x plus 14 equals 7x plus 21, because we distribute, take away 7. So combining like terms, we get 7x plus 14 equals 7x plus 14. Huh? If we follow our rules, if we get our x's together, if we take away 7x from this side and take away 7x from this side, we get 14 equals 14. Okay, now hold on. This is still a WTF, but it's not this WTF. Okay, and you're going, okay, Foster's been drinking or doing something weird. Look at the problems. Carefully analyze the problems. This says 12 is the same as negative 9. That's impossible. That can never happen, ever. But this says 14 is the same as 14. Well, you're right. That's true, always. This is always true. Okay. What that means for our answer is we say either it's an identity. Identity means identical, or we use a fancy R, okay, which stands for all real numbers.
For some reason, I keep doing these problems and I'm getting normal answers, not weird ones. Like the last one I got, x is negative 21 over 12. And like this one, x is 0 over
What's 6 take away 6?
nothing.
Yeah, no x's. Your x's dropped out of the problem.
See, I took away 6x from one side, but then I added 6x to the other side and made that.
No, there's your problem. Remember, you have to do the same thing to both sides. If you take away 6x from this side, you have to take it away from the other side to talk. We talked about balance last week.
Oh, right.
You have to do the same thing to both sides. Have to. If you take away 6x from this side, you got to take it away from this side. That's why they dropped out of the problem. If you take away 7x from the right side, you have to take it away from the left side. Do the same thing to both sides. Okay.
Okay, thank you.
Yep. Okay, a little bit of math theory. When we were doing a normal problem and we got x is 2, which we should have said solution set 2, this meant if I plugged 2 into the original problem, it made it true. It made it work out. It checked the original problem, whatever that problem was. And 90%, 99% of all our problems, we get an answer, x equals 2. And 2 would plug back in and check. What this says is no number will check this problem. You can try all your life plugging numbers into this, okay? X is 3, X is 7, X is 1.2, X is what? I don't know. No number will check this problem. No number in existence will make this problem true, will work out this problem. This is saying any number I pick, if I plug it in here, any number I pick will make this problem true. Any number at all. That's what that's trying to say. But you guys, as the students, have to pay attention to the subtleties here. These are both WTFs because the X dropped out. But this is an impossible situation. 12 can't equal -9. Okay. This is always true. And it doesn't have to be 14, by the way. It could be 0 equals 0, or 9 equals 9, or 3 equals 3. The key is they're the same number. Okay.
Is that our answer then? Always true?
No, always true is your thought. Your answers are either this or this.
Okay, got it.
That's a script R. It's okay. One of the things you got to get used to is mathematicians are just plain lazy. And apparently it's really hard for mathematicians to write that word, all real numbers. So they invented a symbol that means all real numbers. Okay. Or just to confuse students even more, they put it in interval notation. They say everything from -infinity to +infinity. Oh, man. Okay, so this particular problem has 4 different ways. 3 different ways, I guess, that you could show the correct answer. I believe mom uses identity, but I don't know. I get confused. Anyway, when you're doing your homework in chapter 2, be aware some of the problems will have these weird answers, and then come back and talk to me. Okay, we'll work them out. We'll figure them out. Okay, I'm done, but don't go because I'm going to take roll. Okay. Stop the recording. Yes. Yes. Okay.